One of the most persistent questions within SETI is the notion of whether aliens might use communications systems other than radio that we are either only just now able to detect or still outright aren't even aware of. Does radio at some point become obsolete? Or alternatively, does it follow our current trend of getting quieter as we advance further? This is problematic, however, in that there really doesn't seem to be anything better than radio for certain tasks, such as radar mapping asteroids. You don't need to spend hundreds of millions of dollars in resources to do some novel form of mapping when a simple energy-cheap radio pulse will do. Or if you will, if you want to melt a candle, you can do it by tossing it in a campfire, but you could also do it with a hydrogen bomb. But there may be other ways of communicating that could be cheap in principle, and we just don't know how to harness them yet. This ranges from questions about spooky action at a distance, where instantaneous connection of some sort seems to happen between entangled particles, but that we can currently think of no way to send useful information using the effect. This in itself is strange. The universe seems to have governors on it that prevent certain things from happening. There are quite a few of these in physics. Why does time move forward instead of backward? Why do a number of parameters have to be just so in order for matter to exist, and so on? But here the big prohibition is faster-than-light communications. The universe does not like this, and you could characterize the speed of light as not only that, but also the speed of time, and ultimately the fastest speed at which propagation of information can occur within the universe. Without it, paradoxes form. But if you remove that key word, information, from the equation, the speed of light rule steps aside, and spooky action at a distance can happen because no useful information is being transferred. The universe's overall strangeness aside, ever since the 2017 Nobel Prize winning confirmation of the existence of gravitational waves, there have been suggestions that gravitational waves might be the preferred way for aliens to communicate over long distances. We have since detected many natural gravitational wave sources with detectors like LIGO that open up the possibility for SETI to search gravitational waves for signs of alien communication. There's an interesting aspect here. The use of gravitational waves over radio might serve as a communications filter. Small-scale up-and-coming, less than Kardashev Type 1 civilizations such as ourselves may use radio, and at our level of technological development, we may not be that interesting to talk to by a galaxy-spanning Kardashev Type 3 civilization. Firstly, though, it must be noted that we now have something around 100 detections of gravitational waves, but they've all been from predicted sources, black hole and neutron star mergers. We have not yet seen anything unexplained. There is not yet a wow signal in the field of gravitational waves. But there's also the question of sensitivity. Our gravitational wave detectors are not that sensitive yet, and indeed they're relative newcomers to the game, and future instrumentation will likely be more precise. As a result, the signals that might come from aliens are still lost in the noise, so to speak. This works the same way in radio astronomy. Many natural radio signals, and indeed the first ones we picked up in the early days of radio, were very powerful. Those huge natural signals were the low-hanging fruit. But as our radio telescopes got better and more sensitive, we now see a much more nuanced, detailed view of the radio sky. We still don't unambiguously see aliens, but we do see all manner of interesting natural signals, some very weak. No doubt this will be the case for gravitational waves, but there's a problem here. There really isn't an easy way to create them without titanic engineering projects. Some serious energy is needed here. In a paper by Marek, Abramowicz, and colleagues, linked to all papers in the description below, they detail that there's a kind of signpost in our galaxy that anyone doing astronomy is going to know about. There are a number of these, but this one is dramatic. It's Sagittarius A star, the supermassive black hole at the center of the Milky Way. Now, if it's not spooky enough that we have a supermassive black hole lurking at the center of our galaxy silently accreting material, it may also be a natural place for a highly advanced alien civilization, far more advanced than we are, to move to. The obvious reason to do this is energy extraction. and for that matter, scientific probing of a supermassive black hole. But what of communication? This is spooky not for the implications of the paper, but what can be sci-fi speculated about it. More on that in a minute. But the idea is that if you really want to use a black hole, you'll need to build massive structures around it. Build a Jupiter's mass worth of structures, and the motion of that should create a signature in a gravitational wave signal that might be detectable. It might even be arranged to be a method of internal communications, so you can communicate over long periods and distances, but still at the speed of light with the rest of your civilization. There are a few things about this, however, that need to be addressed. This really gives you a starting point to look for a supercivilization in the Milky Way. The center of the galaxy is a highly radioactive environment with stars packed very closely together. It's unlikely that life could ever gain much of a foothold in that environment without technology, so the center of the galaxy lies outside the standard view of the galactic habitable zone, too harsh for any kind of life we can envision. Which means that if it is inhabited, someone technological moved there, crossing the vast distances of interstellar space to probe into the center of our galaxy would require a supercivilization. But once they got there, they would have access to an extremely useful supermassive black hole and as much raw materials as they could possibly want. Everything's concentrated there. But it's also a somewhat radio-loud area, and not really an area well searched by SETI. Even still, if you want to look for a supercivilization in the Milky Way, Sagittarius A star would be a prime candidate. For our purposes as primitive humans, we'd want to look to see if there's any weirdness or anomalies in gravitational waves coming from the vicinity of this supermassive black hole. But there's a problem. There's no shortage of lower mass black holes in the galaxy, but there's really only one black hole on this level, and that goes for most galaxies actually. Unique real estate in the galaxy as far as competing alien civilizations is not good. It means that there lies in our galaxy a potential holy grail that all civilizations within it are eventually going to want control of. This is bad. If the supermassive black hole, Sagittarius A star, indeed holds properties that would be of great value to any civilization of sufficient technological prowess, then that's where you might look for interstellar wars, a potential focus for such things. And given where it's located, there's no guarantee we'd have any method within Radio SETI in which to clearly see such a war. Wrong area of the galaxy for that. But it may be preemptive, in that the reason behind any kind of zoo hypothesis scenario is not the usual things I talk about on this channel in this regard, such as stopping the development of generalized artificial intelligence or dangerous nanotechnology, but rather access to the supermassive black hole at the center of the galaxy. So how do we probe just what might be going on in the center of the galaxy? The best bet may be gravitational waves. We don't really yet have a plan for a really sensitive gravitational wave detector suited for this purpose, at least until now. In a paper by Jani and Loeb, the authors advanced the idea of a gravitational wave detector across the gravitational wave spectrum that could be implemented by the new NASA Artemis launch system. The idea is that a lunar-based gravitational wave observatory could be ideal for looking at certain frequencies of gravitational waves in an ideal way. This is interesting because it's been known for a long time that in radio astronomy, a radio telescope on the far side of the moon would be extremely useful, especially in SETI, where the moon would block most of Earth's radio interference and get cleaner signals than the huge interference mess we have now. This is interesting because it could allow for a detection of a gravitational wave on the level with an asteroid hitting a planet, like what killed the dinosaurs, as opposed to the enormous gravity-loud neutron star mergers we can detect now. Better resolution, at least at certain frequencies. Though you'd need to be doing this a lot as an alien civilization for us to be able to see it. Earth doesn't get hit by such asteroids very often, but if you're doing it intentionally as a kind of orchestrated shooting gallery, then it might be a technosignature. But there is another option. In a paper by Luke Sellers and colleagues, they show that even before getting into future gravitational wave detectors, it's possible that LIGO, which already exists, could be useful in SETI searches. Here we deal with just how big of a spacecraft an alien civilization wants to accelerate. We don't know what aliens do, but if they had spacecraft the size of Jupiter, we might actually be able to see such a spacecraft being accelerated. They term it a Raman craft, and LIGO might actually be able to see one of Jupiter mass being accelerated to a significant fraction of the speed of light. Searching for and studying gravitational waves are the wave of the future for us now that we have actually detected them, something Albert Einstein once wrote a paper that suggested they didn't exist, even though they were a prediction of relativity. In the future, NASA and ESA are planning a gravitational wave observatory in space called LISA, or Laser Interferometer Space Antenna. How this works is that you have 3 spacecraft widely separated that shoot lasers at each other and detect minute variations in distance as gravitational waves distort everything as they move through. This is how LIGO works, but on a smaller scale. These detectors literally look for distortions in the fabric of spacetime caused by gravitational waves. This is where you could detect oddities going on with Sagittarius A star, and even messages. And there is an advantage for doing it this way. At the right frequencies, nothing can block such a message. Electromagnetic waves can be obscured and blocked by interstellar dust and gas and Earth's atmosphere, but not this. We are truly entering a new phase of SETI, and for those that make the entirely valid argument that maybe we don't know how to look for aliens, at least we're getting better. Thanks for listening. I am futurist and science fiction author John Michael Godier, not at all happy with the center of the galaxy. We're out in the backwater just outside some spiral arm, but the real action seems to be in there. What if it's like a club where you have to reach the civilization equivalent of 21 years old to get into, say 21,000 years of high technology, only to find out that it's really not that great? Such are the worries of an adolescent technological civilization, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.